right. Chapter 7 is going to be putting together all of the things we've kind of been talking about already with the standard normal distributions and the t distributions and our means and our variances and our standard deviations and putting all these things together now to start testing hypotheses. So there's going to be a claim that's made, and we're going to use statistics to test whether that claim is true or not true. In section 7.1, we're not going to be quite testing yet. We're going to be kind of talking about all the vocabulary and things you need to know to be able to do the hypothesis testing. So really the bulk of the math that we're going to be doing is in 7.2, 7.3, and 7.4. 7.1 is going to be a lot of like vocab and getting used to terminology that's going to be used in the chapter. Okay, so first thing that's on your paper, and we're not going to really spend a ton of time on this right now, I just wanted to mention it. We did not do section 6.3. It is not in our syllabus, but the population value for a proportion does show up in this section. So P represents the population proportion, and it's really a percentage. So if we say P is 0.52, it means we're saying that 52% of the population does X, Y, and Z, whatever the claim is, okay? This formula to calculate P hat, which is a sample population. So maybe on your paper, well, it actually already says that there. Sample population is P hat. Where it says P in between the confidence interval here, maybe label that as population or one arrow to the word population there. You're just going to see it show up and just know that it represents for right now a percentage. When we get to section 7.4, we're going to come back to these formulas and we're actually going to calculate the confidence interval for proportion and all of those things. But for right now, you don't need to know how to do the calculations. You just need to know what is P, and P is a proportion for the population. Okay, but we'll come back to these formulas later on. All right, so hypothesis testing is what we're jumping into now. Hypothesis test is a process that uses sample statistics to test a claim about a population parameter. So that's important. Our claim will always be about the population. Not necessarily always about the mean, but we're going to use mean a lot because we did that with our confidence intervals. It might be a standard deviation that there's a claim about, or a variance that there's a claim about, or a proportion that there's a claim about, but it's some population parameter. And then we're going to use statistical hypothesis, so we're going to use statistics to test that hypothesis later. All right, two pieces that make up a hypothesis are the null hypothesis and the alternative hypothesis. In every problem you do, there will be both of these. There will be a null and there will be an alternative. So you need to know, first of all, how to tell the difference between the two, especially if it's not labeled. A null hypothesis is a statement that has equality. So either less than or equal to, or greater than or equal to. So if there's an equal sign, it is the null hypothesis. The alternative hypothesis is the complement of the null, meaning whatever the null is, the alternative is everything else. And it will not have equality in its statement. So it might be strictly greater than, or less than, or not equal to, and that is the alternative. Okay, so again, every hypothesis test will have both a null and an alternative. The null is the statement with equality. The alternative is the complement of that. It will not have equality. Okay, so the first thing that we're going to do with these is just kind of get a graphical picture of the different ways that a null and an alternative hypothesis can look. When you are hypothesis testing, either the null or the alternative can be the claim that's being made that we are then testing, okay? So here they've got it labeled which one's the claim and which one is not. They also have it labeled for you which one is the null, that's the one that has the sub 0, and which one's the alternative, that's the one that has the sub A. All right, so the first one is a claim about the population proportion. If I were to read that word, I would say the population proportion is 61% of, whatever it's calculating for that problem, okay? So I'm going to put 0.61 on my number line. And the claim is that it's equal to 0.61, so I'm going to make a solid dot, and I'm going to label that my null hypothesis, H sub 0. My alternative hypothesis is everything else on that number line. It's complement. So the alternative hypothesis would be everything above 0.61 and everything below 0.61. So that's what not equal to 0.61 would look like, everything else on that number line. Another way the null hypothesis can look, it can be, here it's our population mean is less than or equal to 18 years. If I were going to graph that, again, say I would choose 18, my solid dot there. And then everything less than or equal to 18 is my null hypothesis. The claim is that the population mean is greater than 18 years. That's my alternative hypothesis. So I'm going to graph these. I'm going to put an open circle there so you can kind of see the difference. It's greater than, but not including 18 is where the alternative hypothesis is located. And then the last one, again, it's population mean here. The claim, again, is the alternative hypothesis. The claim is that the, whatever it is less than 15 minutes, the population mean. 15 minutes of what? We don't know. I'm going to go ahead and graph 15. And I'm going to do my null hypothesis first. It's greater than or equal to 15. So 15 and everything to the right is my null. And then its complement, the alternative, is everything less than 15, but not including 15. Okay? All right. So what we're going to do first on the back side of your paper with this is we're going to practice if we're given a claim, writing its complement and then labeling which one is the null and which one is the alternative. Okay, so this first one is about variance. That's our little mu squared is variance. The claim is that the variance of whatever is greater than or equal to 1.2. What is the complement of greater than or equal to? It's everything else, right? Which would be what? Think about the number lines. It would be less than. All right, so the complement, I should say, is less than 1.2. Still variance. All right, for the one in the middle, this is a statement about standard deviation. That's that symbol. The claim is that the standard deviation is not equal to 5 whatever. So what is the complement of not equal to? Equal to. So standard deviation equals 5. The last one is a claim about the proportion of the population. The proportion is less than 45%. What is the complement of that? P is greater than or equal to 0.45. And you can see when those are written, it's always going to be a decimal. All right, so now let's go back and name which one is the null and which one is the alternative. As long as you remember that the null is equal to, this should be very quick and easy. The null is equal to, so it's my variance is greater than or equal to 1.2, which means the alternative, its complement, is less than 1.2. In the middle, my claim is the alternative hypothesis, not equal to, and the null is its complement, equal to. And then it's going to be the same situation for that last one. The alternative hypothesis was the claim. The null hypothesis is the complement. Okay? All right. The other thing that we're going to do with this today is we're going to take a statement that is in words and try to translate it into a mathematical statement like this to write our null and alternative hypothesis. In order to do that, you need to know what all the common phrases and things you're going to see in these kind of word problems are, so you're able to then translate it to that mathematical equation. So on your chart here, you guys are going to fill this in. There are three pieces in the middle we're going to fill out first. These are the three ways our null and alternative can look, what we talked about with the number line. So the null can be greater than or equal to, and the alternative can be less than. The null can be less than or equal to, and the alternative can be greater than. And these are all written with population mean, but it can be any population parameter. And then the last one is the null could be equal to, and the alternative could be not equal to. Now remember, either the null or the alternative could be the claim that's being made. So you might see what's going to appear on the left here as the claim, and that would be the null hypothesis. Or you might see what's going to appear on the right here in a minute as the claim, and that would be the alternative hypothesis. You're going to see a lot of opposites in these columns. All right, so when you're ready, I want you to get all these little phrases in those boxes. Okay, this is going to be a nice little chart to have later on to refer back to. So if you find a phrase and you're not sure, is that less than, greater than, equal to, not equal to, you can figure out how you're going to write your null and your alternative. And I know it seems like we're going like really slow, and I'm being a little, I don't know, taking it a little slow, I guess I should just say, as we go through here. But it's going to be really important when we get to the hypothesis testing that you can write the null and the alternative correctly, because then everything else we do after it is going to be based on your claim and your hypotheses. So we want to make sure that we get this accurate and right and practice it before we move on to the next step. Okay, and then I'll just kind of show a couple of these at a time. In the middle, you have, again, a lot of opposites. You're going to see a lot of similar wording between kind of diagonal boxes here, what you see in the middle on the left, what you see on the top on the right, less than or equal to, fewer, not more than, shorter than, not longer than. So again, we kind of see complementary statements. And then the ones for equal to, not equal to at the bottom there. I'll give you guys a minute to get these all written down, and then we'll practice with them. Are we good? Do you have them? Okay. All right. So we're going to do these few together here, and then you guys will have a chance to try it. So each of these is a claim that we're going to write as a mathematical statement. And if you're not sure about the wording, you can look back at that chart you just wrote down and find it on there. Then we're going to write the claim. We're going to write its complement. And then we're going to label which one is the null and which one is the alternative hypothesis. All right. So number one, a consumer analyst reports that the mean life of a certain type of automobile battery is not 74 months. All right, so remember that your population parameter is going to change from one problem to the next. So it's important to kind of underline, circle, highlight, whatever that is. In this case, it is a claim about the mean of the population. And the claim is that it is not 74 months. All right, so claim is that my mean, which is my capital mu there, is not equal to 74 months. What is the complement of that? What is the complement of being not equal to 74? Equal to 74. And then once we have both, you're going to label which one is the null and which one is the alternative. So in this case, the claim is the alternative because it is not equal to, and the null is the complement equal to. Let's try the second one. An electronics manufacturer publishes that the variance of the life of its home theater system is less than or equal to 2.7. So the population parameter is variance here. So my claim is that my variance, which is my little mu squared, is less than or equal to, that's pretty straightforward, less than or equal to 2.7. What is the complement of being less than or equal to? Greater than 2.7. Is the claim the null or the alternative hypothesis? It is the null. Good. All right, last one together. The claim is that a realtor publicizes the proportion, that's my population parameter, of homeowners who feel their house is too small is more than 24%. So my claim is that my proportion P is more than, greater than 24%. We're going to use a decimal, 0.24. What is the complement of that? P is less than or equal to 0.24. In this case, is the claim the null or alternative hypothesis? It is the alternative hypothesis, and the null is the complement. Make sense? All right, so there are 4 more problems on your paper. These 4 right here. And conveniently, there are 4 groups in this room. How perfect is that? So I'll come around in a minute and I'll tell you which one you guys are in charge of. We're going to do the exact same thing we did in the previous problem. So you're going to write your claim as a mathematical statement. You're going to write its complement as a mathematical statement. Label the null and the alternative. All right, go ahead. So claim, 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 claim. And the only one I'm going to change is actually the last one. So you don't have any words there that are more, less, at least, greater than. There's nothing like that. So this is an equal to, not equal to one. And even though the word did not is there, the claim is that 73% did not. So 73% is, and the rest are not, I guess is the way to say that. So actually, our claim is the null hypothesis, that it is 73% that did not use it. So the null would then be the alternative, sorry, would be the other one there. That one's a little tricky. All right, so Math Excel for 7-1 is due on Friday this week. It's going to be a little different than the other Math Excels because when you log in, you are going to see 3 different assignments. All 3 assignments are due on Friday, but they're smaller than usual. So instead of having one assignment with like 20 questions, there's 3 smaller assignments that have between like 8 and 10 questions in them. So 7-1 part 1, you guys can do all of it tonight. I chunked it so it matched what we're doing in class. So you can do it all tonight. You can do it all in class now, actually, maybe get it done. And then just do 7-1 day 2 tomorrow. 7-1 day 3 will be what we cover on Wednesday, but all 3 of them are due on Friday. So if you need any extra time on any of the 3 assignments, you can. Okay, so don't panic when there's 3 of them. They're 3 mini lessons. Okay. All right. So that is it. You guys can get started on Math Excel, and I will do the cell phone lotto.